Good evening. My name is Shweta KTS and I'm currently a student at Chennai Institute of Technology. For this hackathon, I've chosen the theme 5 Order Busters. This theme focuses on building an AI system that can capture and learn from an individual's tacit knowledge, the unspoken experience, intuition, and decision making patterns, which are often lost when people leave an organization. In the next few minutes, I'll present my proposed solution, explain how it works, and show why it is highly relevant for both Japan and India. In today's workplaces, a large portion of knowledge is tacit. It lives inside people's heads and is rarely written down. This includes knowing when to prioritize one task over another, how to handle exceptions, or how to make judgment calls in complex situations. Japan, in particular, faces a pressing challenge here. With an aging workforce and declining population, decades of tacit expertise risk being lost when experienced employees retire. At the same time, younger employees may take years to absorb the same level of intuition and decision quality. India also faces inefficiencies in workflows where employees often reinvent solutions because decision paths are not properly captured. The key challenge is how can we build an AI system that not only automates explicit rules but also learns these tacit, intuitive aspects of decision making? My solution is called the Cognitive Tacit Knowledge Capture and Automation System. It is designed as a multi layer AI framework with five key components. First, the capture layer. This observes digital behaviors such as emails, task choices, or system interactions. It also uses natural language processing to capture short reasoning prompts from the user at critical decision points, creating what I call micro journals of tacit knowledge. Second, the knowledge graph. All the captured data is organized into a dynamic graph where each node represents a decision, a context, or a factor influencing the outcome. This graph allows the system to map not just what people do, but why they do it. Third, the dual AI engine. One module uses contrastive learning to identify subtle differences in decision patterns. For example, why two similar requests might be handled differently. The other module is a sandbox simulation which tests AI made decisions against historical outcomes before automating them, ensuring safety and accuracy. Fourth, the human AI collaboration layer. Here, the AI assigns a confidence score to every recommendation, and high confidence decisions can be automated, while low confidence ones are presented to the human with clear reasoning options. Importantly, users can replay and review the AI's decision trail, which builds trust and transparency. Finally, the continuous learning loop. Every correction or adjustment made by humans is fed back into the system, refining the knowledge graph and allowing cross domain transfer. For example, prioritization logic learned in a finance department could inform decisions in HR or supply chain workflows. So, this system is effective because it does not simply replace humans with rigid rules, instead, it acts like a digital apprentice learning from human expertise, simulating outcomes, and gradually taking over repetitive yet intelligent tasks while keeping humans in control. So, to bring this solution to life, the implementation would proceed in four phases. Pilot projects in Japanese companies, starting with one workflow such as compliance checks or procurement. Model development in India, where AI engineers design the knowledge graph and contrastive learning engine. And joint testing and validation, deploying the system in hybrid teams across both countries to refine the collaboration layer and scaling across industries, extending the system to HR, finance, supply chain, and customer support. So, the key resources needed include access to anonymized workflow data, domain experts to guide tacit capture, and cloud infrastructure for AI training and simulation. The solution directly addresses Japan's urgent need to preserve tacit expertise in the face of workforce aging. By digitizing and transferring these unwritten skills, Japanese firms can maintain productivity, resilience, and cultural consistencies in their operations. So, for India, this project brings exposure to high value AI innovation beyond simple automation, creating new opportunities for startups and IT service providers. Together, it builds an India Japan pipeline where Japan contributes deep domain expertise and India contributes scalable AI development capacity. The result is a truly collaborative solution with benefits for both the countries. So, my personal interest in Japan comes from its philosophy of shokunin or craftsmanship, the dedication to mastery and precision. This mindset inspires me to design AI systems that are not only functional but also thoughtful and reliable, just like Japanese craftsmanship. I also admire how Japan integrates tradition with cutting edge technology, from robotics to healthcare, which has influenced how I approach innovation in my own work. This blend of respect for knowledge and drive for continuous improvement resonates deeply within me. So, in conclusion, my solution captures and automates tacit knowledge, bridging the gap between human intuition and AI automation. By combining Japan's depth and of expertise with India's innovation, we can create a future of work that is productive, sustainable, and collaborative. Thank you for your time and attention.